Hello everyone, my name is Salad Kunumuri, and today we'll be going into the data types, which is the first actual coding lesson which we'll have. So you may be asking, what exactly are data types? So data types are the building blocks of Python. They allow what we code to become to reality. There are four main data types, but there are more. But we'll be just going into the four more basic ones. The first one is int, and int can be known as an integer, which is basically like a whole number, right? So for example, 6, 342, -17. And please be sure that the negative value does not make an int not an int. So all whole numbers, whether positive or negative, are an int. Next is a float, and float are basically your decimal numbers. Float includes 3.14 or pi, 3.627, 7.0, and -9.80. So basically, anything that has a integer, point, and then some value is a float. No matter if it's positive or negative, just like an int. Booleans are a little more simpler, as they're either true or they're false. That's it. This is mainly used in conditionals like if, elif, else statements, which we'll be going into very soon in like another day. And the last one is string. String is basically like the text. Like for example, whatever I'm saying right now, if put on words on a Google document, that's text, right? So string is basically text, like hello world, to and true with quotation marks around it. That's very, very important. Anything with quotation marks surrounding it is a string, and string is immutable in Python, which we will go into very soon later, but it basically means that you cannot change strings directly once you have made. Now we'll be going into variables. Variables are basically containers that hold the data types. We just went through the four main data types, but how do we use them, right? We store them in variables or as a container, and this basically points to certain values in memory. For example, in the image that you see below, x is equal to 5, right? So that means the integer value of 5 is in the container of x. So if you call the x variable, it'll print out the value 5. So x and 5 are correlated. Next, you have y is equal to x. You may be tempted to say, when y is being called, x is being called, right? But remember, x is a variable. So that means when x is equal to 5 and y is equal to x, this is the transitive property in math. Y is equal to 5 because x is equal to 5. Next, we have z is equal to high. Basically, what this is doing is storing the text or string value of high into z. And this is a diagram of what's going on. So x is equal to 5, right? We went through x is equal to 5. Then you put y is equal to x. So y is equal to x. So they both point at the same 5. That's very important. So that means when y is being called, y is 5. And here, since the z value is high, then when you call z, then it'll call the string. We also have this thing called casting. Casting is basically converting data types into a different data type. And we will frequently be forced to convert between data types, which we'll learn in later classes on when exactly we should use this. But basically, the main point is converting data types into a separate data type. For example, if you're doing this, right? Int and you put the parentheses and you put inside the value, right? So here, like the quotation mark surrounding 10 means that it is a string, because strings have quotation marks surrounding it. So this is basically trying to convert int of the string 10, which, as you would assume, will equal to the int of 10. So basically what we're doing here in casting is we're converting the string value of 10 into an integer value of 10. And the same can be reversed with the stir operation. The stir meaning string. So if you do stir of the integer value of 10, you convert it into the string value of 10, which is shown here. Basically here, we turn the string value of 10 into the integer value of 10. And then the second one, we turn the integer value of 10 into the string value of 10. This can be done for other operations as well, like for float. You have float, which is, remember, the decimal value of 5. 5 here is an integer, and this is basically trying to make it a decimal number. So at the end, it'll equal to 5.0, as that is the decimal value of the integer of 5. And here we have the last example where we're trying to convert a float to an int. Basically, the float is 3.14, and you're trying to convert it to an int. So just by putting the int operation and putting the decimal value in between, it'll convert it to an int value. So basically what it does, it just scraps off all the numbers beyond the decimal, and it will just provide you an int. So it's like a floor function. It will always round down. And some typecasts are not possible, like changing a string to an int and a float into a Boolean. It might be contrary because we just turn a string to an int here, right? But what if the string is hello? How would that be an integer? And that is where it will crash. And float an int to a Boolean, this should be pretty self-explanatory. You cannot turn a number into true or false. And here are basically like the list of all the basic operations which you can do. We will go into more of those a little bit later, but if you want to just have this in your notes, be sure to take notes on this, or screenshot it if you want to. Here is basically all like the operations that are available in Python. So I'll just go through them very quickly, but we'll also go through them later. So we have the addition operation, which is the plus, subtraction minus, multiplication star, division with a slash, modulus with the percentage sign, which is basically like the remainder, right? So if you do 3 module 2, it will return the remainder, which is 1, because 2 cannot go into 3 perfectly. And the double star is exponentiation, and the floor division, which will round to the nearest whole number. And here we have the assignment operations. We'll go into this later, so I won't go into this now. And we have the assignment operators, which we'll go into when we're doing the if, elif, else statements. So let's try to put all of this in action. So if I go into VS Code, which we have installed in the previous class. So if you need to install this, please be sure to go into the previous class where we basically had the entire course overview. Once you have reached here, please say open folder. And I would highly recommend you make a new folder for this. Highly, highly recommend. So if you go into desktop, and if you say new folder at the bottom, and just type in, let's call it learnable Python code. You can just name whatever you want. It should make a difference. So if you press create and then press open, you'll be into this new canvas where it will show you the code here and all of this. Basically, what you need to do now is you need to add a file. So I'll be going through this very quickly. So if you want to add a file, there's a button on the top where it says new file. So just press that. And Visual Studio Code by default does not make a Python file. So you'll have to declare it as a Python file. It should be very easy, as you just need to do .py. So I'll just give an example. So we'll just do data types .py. And because you do the .py, right? If you don't do the .py, you'll think it's a text. But if you do .py, it will be a Python file. So it's very important. Every single time that you make a file, you put .py at the end. And the name can be whatever you want. After you're done with that, just press enter. And you're now into the Python file of data types as it's on the top. If you have any more questions with this, please be sure to email me at my email, which is my first name and my last name at gmail.com, or SAILALITHKANUMURI. And if you need, you could also YouTube on how to use Visual Studio Code for Python, and you also get the answer there as well. Once you have this set up, let's get started on actually coding. So here, let's just start with data types. Let's just declare x as 5. So you just put x space equals space 5. This basically declares x as a container with the value of 5. And now we can declare y. So y is equal to 3. So now this declares the variable or the container of y, and in that container is the value of 3. So you can also relate it to a container of cookies. Imagine you have a container of cookies where the container is the variable and the cookies is the value. So for example, in this scenario, y is a container and 3 is the cookies. And you're basically putting the cookies inside of the container for it to hold that value. So that means this has the value of 3 inside the container of y and value of 5 inside the container of x. So now let's do some operations, right? So let's declare z. Z, we'll just type it in as a variable. And let's just equate it to x plus y. And if you were in a math class, you'd be very stumbled on how does this make sense, right? We didn't declare z yet. So how can we make it so that x plus y is equal to z? We don't know what z value is. So x plus y is 8, right? No, x plus y is 8 because 5 plus 3 is 8, right? Because x and y is a container with the value. So whenever you're calling the container, you're replacing it with the value. So this is 8, right? So how can z should be 8 for this to be true, right? But this is the difference between math and Python or coding in general. Whatever it first does, Python first reads the left side of the equal sign. So read this first. So once x plus y is computed, so x plus 5 is 8, then we'll replace it with 8. And then it will store 8 as a value inside the container of z. So that means this example is basically the same as the above. But basically what we're doing is we're making it more dynamic here by putting x plus y. Hopefully that makes sense. We can also do increment operators. So we can do x is equal to x plus 1. Again, you may be completely stumbled. How in the world does this make sense? How is x equal to x plus 1? That doesn't make any sense, right? But again, Python first computes the left side of the equal sign. So x plus 1, so if x is 5, right? X plus 1 is 6. So now it declares 6 inside the variable x. So it boots off the 5, bye-bye, and then it replaces 5 with 6 instead. So if I just run this, don't worry about what I'm doing yet. I just want to show you what I'm doing, like show you that it works. So do print z and then print x. Yeah, don't worry about it. We'll be going into this in our next class. And now if I run it with the run button on the top, you'll be seeing that z is 8 and x is 6, as said above. Or instead of that, I can do x plus 1. So now x is still 6. So replace that 5 with the 6. Hopefully that makes sense. Next, we'll be going into text. So if you do text is equal to, remember the quotation marks, learnable. So here we're basically storing the string value of learnable into the variable called text. Again, the names of these variables can be whatever you want. I can name this like hello, or I can name this like hello, and it will still be very much running, right? So variable names don't matter at this point in time. So you can just name it whatever you want, right? You just cannot name it a data type variable. Like you cannot name it int is equal to that. That won't work. So this is basically storing the string value of learnable into text. And then we can also do num text is equal to 3. Again, what this is doing is it's storing the text value of 3. So Python doesn't think this is a number. It thinks it's a normal string and storing that into a variable called num text. And then we can do typecast here. So text is equal to int of, I don't know, or we can just do text here. And this should work, right? You said, no, you are very much correct. This will not work because like we said before, learnable cannot be converted to a number because it's multiple characters, right? So it cannot be converted. So if I run this, it will be saying it's an error. Invalid. Okay, no need to read this, but just see value error. Value error means it cannot convert it. So let's ignore this for now. Now if I put num text is equal to int num text, if I run this, this will work. See, nothing happened. Or I can delete this. I can run again. See, nothing happened. That's because num text is with the value of 3, right? At least Python can infer that value. Learnable, like this cannot be converted. But the only thing that's preventing this to be a number is that quotation marks. So Python removes the quotation marks and replaces the quotation mark 3 to a number 3. And we can just declare Boolean, bool is equal to true, or it could be bool is equal to false. Should make a difference. And then this is basically variables, typecasting, and data types in a very quick manner. So if I go into the code, this is the first homework. Hopefully, this won't take more than 10 minutes, as this is mainly to test your knowledge on what we did so far. So what is the difference between an int and a float? How do variables work? Casting operations, and then just solve all these. What is the result of 4 is equal to 4? And is 19 not equal to 21 true or false? Remember, the double equals to is basically like comparing them. If you put the equals to, if the 1 equals to, you'll basically be assigning 4 as 4. And here, the not equal to basically means that is basically the exact opposite of this. So I can just answer these for you, making your homework less. What is the result of 4 equal to 4? So this is basically saying, is 4 equal to 4, right? Remember the double equal to, always replace it with equal. So the one equal sign means you're assigning. Double equal sign is comparison. Remember that. So is 4 equal to 4? That's true. So 4 is true. And 5 is 19 not equal to 21. Okay. 19 is not equal to 21, but there are people who think it is, and and they're wrong, right? Because they're two different numbers. So not equal to and equal to, remember those. So just do 1, 2, 3, and if you want, you can do 4, 5 again, and keep up the amazing progress. This is very hard. You're starting a new chapter of computer science because this is one of the most hardest fields you can ever do. So just by participating in this course, you did yourself a huge favor and are up to an amazing, fun, and interesting challenge. So thank you so much for watching this, and I'll be sure to see you in our next video, where we will be going over the homework, and then afterwards, we'll be starting on our next lesson. Thank you.